So today we are going to talk about compound interest and just how to calculate it. The formula would be given to you, but you have to know how to use it. I'm not going to tell you what all the variables stand for. You need to be familiar enough with it to know that part. So first, just some common terms that you are going to hear as we go through this. If I say something is compounded annually, what does annually mean?
Once per year.
Once per year. Yep. Annually is one time per year. What does semi-annually mean? Every 6 months, so we're just going to say 2 times per year.
Then biannually, I was thinking biannually.
Yeah.
Biannually is every other year.
Yes.
And probably triannually would be every third year.
What would quarterly mean?
Once every
3 months.
Every 3 months, so we'll just say 4 times per year.
Now let's take a wild guess what monthly means.
I know. What's monthly? How many times a year? Okay. Now, the last one, you would be amazed at how many people don't know this. How many days are in a year? Assuming not a leap year. 365 times.
That's a common payment period.
I
I mean,
think
daily payment.
that'd be a lot of checks.
That would be a lot of checks.
Well,
I guess that'd be
compounding
like food.
interest. You don't necessarily have to pay it every day, but you would. They charge you interest every day.
Oh, so that'd be like a credit card or something like
Yeah.
that. Okay, that makes sense.
If you have a late payment, you get
Yeah.
assessed interest every day.
Okay.
10 cents.
All right. So the 2 types of interest we are going to calculate. We have done simple interest before, but in terms of compound interest, the first one is our typical compound interest formula. So it's A, meaning your future value or your ending amount. So A is what you are going to owe at some point in the future, equals P1 plus R over N DNT. P is your principal, or your starting amount, sometimes called your present value. R is your interest rate. It has to be in decimal form. N, the number of times a year you are compounding, and T is the number of years. Okay, so on a test or quiz, I would just give you this formula. You'll have to be familiar enough to know what the variables stand for, but I did put it at the bottom of that slide for you. The second one, okay, we stopped at compounding daily, but could we compound more often than daily? Could I do every hour, or every minute, or every second? That's leading into continuously. So the second one you only use if you hear the word continuous in the formula. So if it says continuous compounding, the formula is a little bit easier. A equals PE to the RT. A, P, R, and T have the same meanings as before. E is actually a button on our calculator. It's kind of like pi, it has a set value. And the reason why that works is kind of a calculus concept, so just trust me that that's the formula. Okay. So,
Said we will.
you will. You're not going to ask me to explain it. I mean, I could, but it involves some limits and things that we haven't talked about yet. So. All right, so what we're doing today is just reading problems, figuring out what to plug into our formula. My recommendation is to write down all the variables that we have, and that way it's a little bit easier to solve for what we're missing. So if I said find the future value is what variable? A. So I'm just going to write down A equals question mark. That's what I need to find. Of $100. So what do you think the 100 is? That's P. That's what I have right now. Invested at 4%. Your percent is always your rate, but you have to do decimal form. So 4% would be? It is. Compounded quarterly, unless you have to owe somebody. So quarterly, how many times a year would that be? So it's every 3 months. So N is the number of times per year it's compounded. So if we're doing it quarterly, that would be 4 times a year. After a period of 13 quarters. Okay, here's one thing we need to mention. On this, T has to be in years. I told you we're doing it for 13 quarters. How would I change that into years?
13 times 4 divided by 12.
More
Do
complicated.
13 divided
No, 13 by 3 times.
We just have to do 13 divided by 4. If it's 4, we know every year has 4 quarters.
four, or 3.
So if you plug that in, you get 3.25. Okay, you're welcome to keep it as 13 over 4 if you want. So I didn't say continuous interest, so we're using the formula. A equals P1 plus R over N to the NT power. And we plug in what we know. P is 100, 1 plus R is 0.04 divided by 4. And my exponent gets 4 times 3.25. Now we just put all that in our calculator. Honestly, I recommend almost just putting the entire thing in at once. You're less likely to make mistakes that way. But I do want everybody to do that so that if you're not getting the right answer, we can figure out that you're plugging it in wrong. So everybody needs a calculator. Everybody better be putting this in right now. So I am just typing in 100 parentheses. 1 plus 0.04 divided by 4. My exponent is 4 times 3.25. It is money, so we'll round to the nearest cent. So did you guys get 113.809, so 81 cents? Your ending amount is always going to be larger than your beginning amount. So A is always bigger than P. Did everyone get that when they plugged it in?
Do we need to put another parentheses around the division itself inside?
You shouldn't have to because it'll follow order of operations. It'll divide before it adds your 1 anyway. So
We
that's
don't have to label or anything like that, or?
just throw a $sign on there. So my future value, that was what I asked in part A. Part B is the amount of interest you earn. How do you calculate your interest?
Take 113 minus 100.
Right. The amount of money you ended with minus the amount you started with. Just A minus P.
Just take 100 times 0.04 and that's how your interest too, wouldn't it?
That would be simple interest, not compound.
Oh, okay.
So we get $13.81 interest.
The difference being that after the first month or first term, quarter, you get to get the interest on that
Right.
extra.
So compound interest accrues faster. What it means by compounding, if it says quarterly. So that means after the first quarter,
You get an
I
extra
stop, I
$4.
pay you the interest on that 100, so now your balance is bigger than 100. So for the second quarter, you're earning the 100 plus that interest.
$4.
Yeah, $4-ish. And so then you're getting interest on a bigger amount. So each quarter, the amount of interest you earn will be a little bit more because you have more money in the account. Does that make sense? So that's what's happening with compound interest. It's just easier for us to put it all into one formula than it is for us to calculate that interest every quarter and then put it all together. Especially if it were daily or something like that. We don't want to do 365 calculations, we want to do one. So that's where the compound interest formula comes in. Is that one okay? We're just going to try some more. Leah must pay a lump sum of $15,000. What amount deposited today at 4.8%? So 4.8% is my, so R, but what would I put in my formula? compounded annually. What does that tell me? So n is one time per year, will give $15,000 in 42 months. Is 15,000 what I have today or what I have in the future? That's the future. So my A is 15,000. I'm trying to find the amount today, so I'm looking for P this time. 42 months, I have to change that into years. How would I do that? And we get? So we're doing the same formula, but we have different information. A is 15,000 equals P 1 plus 0.048 over 1 to the 1 times 3.5 power. Alright. You're welcome to simplify this a little bit, but we don't want to do too much. If I do 1 plus 0.048 divided by 1, that's 1.048. 1 times 3.5 is 3.5. But I don't want to put this in the calculator yet. I want an exact answer. So what I'm going to do is go ahead and divide this over. So what I'm typing in is 15,000 divided by 1.048 to the 3.5 power. And I want everybody to put it in your calculator so we can make sure we're getting the right answer here. Right. We have to round to the nearest cent, so what do you get? That makes sense because I told you P has to be smaller than A. So under these conditions, she would have to start with $12,729.
I got 1272.
You did 1,500 instead of 15,000. Other questions? Let's look at part B. So let's say she doesn't have that much. If only 10,000 is available to deposit right now, what interest rate is necessary for the money to increase to 15,000 in 4 years? So the 10,000 would be what variable? Principal. And my final amount, my future value A, is still 15,000. I want what interest rate? So I'm looking for which variable? My time is now 4 years. I didn't include it, but let's assume it's still compounded annually, like it was above. So in part A, I said compounded annually. I didn't tell you otherwise in part B, so let's assume that's still the case. So A equals P plus R over N VNT. So my A is 15,000 equals 10,000. 1 plus R over 1 to the 1 times 4 power. So this would be 1 plus R to the 4th. I've solved for R. What would we do first? Not subtract, it's multiplied, so,
Undistributed.
you can't distribute because of the exponent. So the opposite of multiplying would be dividing. So we wanna move it to the other side, but since it's multiplied, we divide it. So we get 1.5 equals 1 plus r to the fourth. Okay, we've solved these types of equations. How do you get rid of a fourth power? Typically, we add a plus and minus with it, but can you have a negative interest rate? No, so we don't need to here. And then to get r by itself, you would just subtract 1. So I could do the fourth root of 1.5 minus 1. Minus 1 is not under the radical. So I got 0.10668, so that would be 10.67%. How are we doing with these? So we're calculating interest, but I might ask you to solve for any of the variables in the equations. So you have to kind of combine what we were using with solving exponential equations with our interest formulas. Any questions there? I am going to jump around a bit. Let's go to this one next. So I'm skipping the next example and going to the one after that. So find what investing $1,000. So if you're investing 1,000, which variable is that? Is that what we have right now or what we'll have in the future? Principal, what we have right now. And the annual rate of 10%. If your rate is 10%, that means R is 0.1. Compounded continuously. When I see continuous, what does that tell me? More than every day. So we don't know how many times per year it's continuous, so we use the continuous formula. For 2.5 years, so that would be my time. So because it said continuous, we're using this formula. That means we don't need an n. So A is 1,000 e to the 0.1 times 2.5 power. You can plug this all into your calculator at once. To get to the e, you have to do second and then natural log button on your calculator. So if you do second natural log, it should bring up the e, and then you type in to the 2.5.
What's the natural log?
The L is like, which calculator do you have? Second on that button, see it's got that e.
Oh, right here.
So if you do second on that L.
How you doing here? Second.
Do we put in 0.1, right?
So 0.1 times 2.5.
Should we put parentheses, I guess,
What do we put in?
What'd you get, 2.5 years? Oh, shoot, right.
Point one.
Did you guys all get it? Alright. You didn't type in the 1,000 in front of it. Anything else there?
Should we, should we run to the hundredth place or the thousand?
We're talking about money, so the hundredth, nearest cent. Let's try this one. Find the present value. I'm looking for present value. What variable is that? P. Of $100. So what does that mean the 100 is? Your P and your A are your $2 amounts. After 2 years, so the T is 2, at 6%, so my rate is 0.06, compounded monthly. So my N is number of times per year.
So would, so we're trying to find if we put in $100 2 years ago, how much percent would be now?
No, if we ended with 100, how much should we put in to begin with? Because we're finding the present value, so we're finding with P. So we're finding what amount we started with. Plug in. You are welcome. You can simplify all this, but if you want, we're putting it all in the calculator anyway. You're welcome to just divide by that whole thing. If you don't want to do the simplifying in the middle, you can type it all in the calculator. So 1,000 divided by 1 plus 0.06 over 2. Oh, sorry. Yeah, I wrote 100. I said 1,000. So we're looking for P. P is always smaller than A. If we're going to end with $1,000, we have some amount less than that today. Sorry, if we're ending with 100. I'm saying 1,000.
So is this debt that they still be owing, or is that?
It's basically just saying if we have $100, if we are going to end with $100 in the future, or maybe you want to make an investment so that you have $100, how much money would you have to put in right now under these conditions? All right. How are we doing with these? We may not do all the examples. I'll do at least 1 or 2 more for sure. But we can go back and do the others if we need to. I want to try one like this. What annual rate of interest? So I'm looking for my interest rate, so I'm looking for R. Compounded semi-annually. So how many times a year is that? Should you seek if you want to double your investment in 5 years? So my time is 5. But I didn't give you the A and the P. All I said is I want to double it. We know it's not continuous, so we're using this formula. My recommendation seems to be the easiest if we just make up an amount here. So how much money do you want to pretend we have today? $1,000. If I'm going to double it, how much money would I end with later? 2,000. Okay, it won't matter what amount you put for P as long as your A is double that amount. So if I started with $10, I would end with 20. If I started with 200, I would end with 400. So we're just making that up for the doubling. So then if if I plug in 2,000 plus 1,000, let's R over 2, the 2 times 5 power. How would you move the 1,000? It's multiplied, so we have to divide it. And so that gives us a 2. 2 times 5 is 10. How do you get rid of a 10th power? 10th root. Again, we don't have to do plus and minus because my interest rate has to be a positive amount. That's going to be an ugly decimal, so I'm not going to put it in my calculator quite yet. What would I do now? And then? Hmm.
I got 0.1435, so let me do it now.
If you're going to double your investment, you're going to have a pretty high interest rate. Alright, you guys tell me, do we need more or are you feeling good with this? Just a matter of plugging into one of two formulas. The only time you use the formula with the E is if it says continuous. And then you're solving for whichever variable you aren't given. Do you guys feel okay with this? There is a handout posted on Google Classroom. So you have time to work on that now and ask questions. Answer key in the folder.